Hey guys, this is CHEMPLIFIED and today we will talk about ideal solutions from the topic solutions. In the previous video we talked about Raoult's law. If you haven't watched that video, please watch it because we will use Raoult's law in this video. Now, let's come to the topic. What is the meaning of ideal solutions? In my video, I will take two liquids A and B and consider them to make a solution which is ideal solution. Now, what is the definition of ideal solution? A solution which obeys Raoult's law exactly at all concentration and at all temperatures is called an ideal solution. Now, what is Raoult's law? Partial pressure of a component A is equal to vapor pressure of pure component A multiplied with mole fraction of A. Partial pressure of component B is equal to vapor pressure of pure component B multiplied with mole fraction of B, and total pressure of the solution is equal to partial pressure of A plus partial pressure of B. This is your Raoult's law. This is your Raoult's law, right? Now, for an ideal solution, the solution must follow Raoult's law at all temperature and concentrations. Then it will be an ideal solution. Now, in an ideal solution, AA interaction is equal to BB interaction is equal to AB interaction. Now, first of all, remember it for the upcoming videos also. Whenever I talk about the term interaction, it means I am talking about the force of attraction. Force of attraction between particles. Which particles? First particle A and particle A, then particle B and particle B, and the third one is particle A and B which are present in the solution. The force of attraction define various properties. In ideal solution, these interactions are equal. All interactions are equal. Consider an example. We have a closed container in which A is present in solution as well as in gaseous state, plus we have another container in which B is present with gaseous vapors. When you mix these two solutions, you will have a container in which A and B both are present, with gaseous vapors, right? Now, whenever I am talking about interaction, I already told you that I am talking about force of attraction between the particles. In this container, only component A is present. So the force of attraction between the particles is between A and A. In the second one, the particles are B. Particles are of component B. So the interaction is between particle B and B. But in the last container, the two particles are present. AB, both are present, and their interaction, the interaction of particle A with B is equal to the interaction of particle B and B and A, which means there is no change in force of attraction whether the particles are present alone or the particles are present in the container together, right? So the overall interaction is zero. The particles are not showing any kind of interaction, means the vapor pressure is also same, the volume is also same. There is no change in volume, there is no change in pressure, there is no change in enthalpy, right? So these terms will remain zero. Change in volume, change in pressure, and change in enthalpy, right? That's what make a solution an ideal solution, when all the interactions are zero or same, right? We will talk about individual characteristic. Now, what are the characteristics of an ideal solution? Volume change on mixing should be zero. Delta V should be zero. When you mix the two solutions A and B, when you mix the two liquids together, the volume change is zero. Means if solution A is 10 ml and B is also 10 ml, then A plus B should be equal to 20 ml. That's it. There is no change in volume. That is, there is no increase in volume, no decrease in volume. Yes, the volume can increase or decrease depending upon the vapor pressure or the characteristic known as volatile or non-volatile liquid. If the liquids are volatile, the vapor pressure will increase, the volume will decrease. We will talk about that in non-ideal solutions, so don't worry about that. Just remember, when you mix the two solutions, the final volume is also equal to the sum of the two solutions. Now heat change on mixing should be 0. For ideal solution, heat change should be 0. That is, delta H should be equal to 0. What is the meaning of this statement? Delta H should be equal to 0. It means that heat is neither absorbed nor evolved during the whole process. Overall, heat is neither absorbed or evolved. Means the reaction, the process of mixing the two solutions is neither endothermic nor exothermic. Right? Now, third one, there should be no chemical reaction between liquid A and liquid B. In simple terms, the liquid A should not be able to react with liquid B to give another product. Alright. Fourth one, ideal solution must obey Raoult's law at all concentrations and temperatures. We have already read that in our statement. Now comes the fifth one. Observed vapor pressure should be equal to calculated vapor pressure. Observed vapor pressure should be equal to calculated vapor pressure of both the components alone as well as the solution. Right? Now comes the thermodynamic terms. These are really important. First one is delta S, entropy. Entropy of mixing. Entropy of mixing is always greater than 0. And the next one is delta G. Gibbs free energy is less than 0. Why entropy of mixing is greater than 0? Because randomness increases after mixing the solution. That's why entropy is greater than 0. Why Gibbs free energy is less than 0? Because this makes the process spontaneous. The mixing of two liquids to be spontaneous, delta G should be less than 0. Now remember these two terms, delta S and delta G. Whether it is ideal solution or whether it is non-ideal solution, the value of these two terms, delta S and delta G, will never change. The value of delta S and delta G will never change. For ideal solution, for non-ideal solution, these values will not change, but these values will change. Delta V and delta H will not be equal to 0 in case of non-ideal solutions. Now, non-ideal solutions are of two types. In both the types, delta V and delta H value will change, and we will discuss that later in the upcoming videos. But for now, just remember, for ideal and for non-ideal both, delta S and delta G will never change. Right? Now let's take a look at the graph. This is the graph for ideal solutions. Ideal solutions. At this point, let me change the color. At this point, this is an origin, this is the second origin. You can make two graphs in one diagram. Now at this point, mole fraction of A is 0, which means, and the other term is mole fraction of B is 1, which means at this particular point, only component B is present. Only component B is present means pure component B is present. And the pressure shown by the vapor pressure shown by the component B at this particular point, is the vapor pressure in pure state, P naught B. Same goes on this side. Here mole fraction of A is 1 and mole fraction of B is 0, which means only pure component A is present. Here the pressure shown is vapor pressure of pure component A. Now this particular line shows the Raoult's law followed by component B, and this line shows the Raoult's law followed by component A, and this is the line that shows Raoult's law followed by the solution after mixing A and B. This is the most simplest graph for ideal solutions. Now we will make some changes when we study non-ideal solution. I hope you understood what are ideal solution. This will be it for today's video. But before we end the video, I shall give you some examples which example of some solutions which behave like ideal solution. Examples that you can relate with ideal solution is benzene and toluene. Benzene and toluene, CCl4, carbon tetrachloride, and SiCl4. These behave like an ideal solution. I repeat, my statement is behave like an ideal solution. These are not ideal solution. They just behave like an ideal solution, right? Another example, ethyl bromide and ethyl chloride. Now the only difference between these two is of halogen. Otherwise, the compound is almost same. So similar kind of solutions behave like an ideal solution. They are not ideal solution. They behave like an ideal solution. All right. So this will be it for today's video. Thank you very much for watching.